Okay, so in this video we will still continue on examples of chapter 1. Okay, for the case of example 4, I'm going to leave it for you to solve for this. I will discuss example 5. Okay, again you are still given a graph, but this time you are given the current graph. Okay, here this is your current graph, current versus time. How are you going to determine the charge if given the current graph? So for this example, there are two methods to solve for the total charge. One is straightforward, another one is quite lengthy. I'll solve. I'll use the method where it is quite lengthy to solve for the charge first, and then we'll discuss on the method that is easier. Okay. So again, whenever you are given a graph, what you need to do is to find the equation for each line. So for this graph, how many lines do you have? 1, 2, 3, 4. You have 4 different lines. So meaning that you need to find the current equation for 4 lines. Okay. So let's prepare the current equation. I of t is equal to from 0 until 1, 1 to 2, 2 to 4, and 4 to 5. Right. Okay, so for the case of line number 1, from 0 until 1, that one is a constant line. From here you can say that I of t is equals to 10 directly. So I can write 10 directly. But if you need to verify, you just write the y is equals to mx plus c equation. So in this case, let's take the points 0 for the first line, 0, 0, and 1, 0. Okay, so your 1, 0, 10, sorry, 0, 10 here, and 1, 10. Okay, so your m is equals to 10 minus 10 over 0. So this one is equals to 0. Okay, and then for y is equals to mx plus c, if you take this line, 10 equals to mx. M times x is 0 plus c. So your c is 0. Rewriting, your I of t in this case is equals to 0x plus 10. So which is equals to this one. Okay, let's move to point 2, 4. Again, you have a constant line here and the value is 5. So you can verify using this method, or you can just directly write 5 here. So the only 2 lines that you need to verify are the lines from 1 until 2 and 4 until 5. So from 1 until 2, the equation is 1. The points are 1, 10 and 2, 5. The m is equals to 5 minus 10 over 1 is equals to minus 5. And you'll see, again, let's take this point. 10 equals to minus 5, 1 plus c. So 10 plus 5 is c is equals to 15. Rewriting, it is equals to minus 5t plus 15. Okay, that's for point 1 until 2. And then from 4 until 5, 4, 5, and 5, 0. Okay, your m is equals to 0 minus 5 over 1. Minus 5 again. And your c is, let's say I take this point. 0 equals to minus 5, 5 plus c. So this will be equals to minus 25. If you carry to this side, it is 25. So this equation is minus 5 plus 25, minus 5t. Okay. Alright. So these are the equations for your current. And you are asked to find the charge at t is equals to 1 second. Okay, at t equals to 1 second. So at t is equals to 1 second, meaning that these are the region. This is the region from 0 until 1. So q of t is equals to 1, 0, I is 10 dt plus q of 0 is 0 because the value is not given. We assume the value is 0. So if you integrate this, you have 10t from 0 until 1. So the value is 10 coulomb. Okay, let's move to t equals to 3 seconds. So total charge, total charge from 0 until 3. Okay, 0 until 3. So in this 0 until 3, how many equations or how many lines do you have? 3. So meaning that to find total charge, q of t is equals to from 2 to 3, which is 5 dt plus 1 to 2, 2 to 1, which is minus 5 plus 15 dt plus from 0 until 1, which is 10 dt. And this part you already solved. This is equals to 10. So what you need to solve is this part. So for this part, 5 dt, this is equals to 5t from 2 to 3 plus minus 5t plus 5, minus 5t here, right? So this becomes 2.5t squared minus plus 15t dt, sorry, 2, 1 plus 10. Okay, equals 5. 3 is 15 minus 10. This becomes 5. And this part is 10. So what you need to solve is minus 2.5 t squared plus 15t. So previously, you have already integrated this and this. What you need to integrate is this part. Minus 2.5 t squared plus 15t. So minus 2.5 t squared plus 15t from 1 until 2. So minus 2.5, 2 squared is 4 plus 15 into 2 minus 2.5, t is 1 plus 15. So this part becomes 12.5 and this part becomes 20. Okay, so 20 minus 12.5 is 7.5. And previously you have this for 3 to 2, you have 2 to 3, 5, and from 0 to 1, 10. So you just add everything, equals 10 plus 7.5 plus 5 and 10. Here should be 5 and here should be 10. So 5 in plus 7.5 plus 10 is 22.5 coulomb. Okay. Next, you were asked to find the total charge at t equals to 5 seconds. So meaning that you need to find charge from 0 until 5. Okay, from 0 until 5. For this part, you need to, meaning that you need to integrate from q of t equals to from 4, 5 and minus 5t plus 25 dt plus 4 to 5 dt plus minus 5t plus 50. This is 4, this is 2, this is 1, 2 dt plus 0 until 1, 10 dt. So if you integrate this, I'm not going to spend more time on showing the steps. So I'm just directly going to give you the answer. If you integrate all the parts, you are going to get the answer equals to 30 coulomb. Okay, so that's the solution where you use the lengthy method. Whereas if you use the shorter method by finding the area under the graph, let's say you want to find the total charge at t equals to 1 second, the area is 1 times 10. So the answer is 10 coulomb. And for 3 seconds, the area is, here is 10, here is 5, here is 5, this is 2.5. So the area is 22.5. Whereas for t equals to 5, the area is 5 here and 2.5. So you get the answer equals to 30 coulomb. So if you have any questions on this example, please let me know.